Welcome to Study Loop.
So the question is asking us to find the sign of angular acceleration. And then we're trying to find also when the angular velocity changes direction, and as well as the angular displacement throughout the entire 7 seconds. So first write our givens. So we have the angular velocity initially is going to be -6 radians per second at t equals 0 seconds. Then we have final. So this means that for A, the angular acceleration is going to be the derivative of the angular velocity with respect to time. And we know that angular velocity is increasing linearly with respect to time. So this will be positive. So that means that the angular acceleration is positive throughout the entire 7 seconds. And then for B, they're asking us, when does this change direction? So we should find the angular acceleration by taking delta omega over delta t. This is going to be equal to 4 minus -6 all over 7. And at this point, we can set up an equation and say that angular velocity is going to be equal to the angular acceleration, rather, is going to be equal to the angular velocity final minus angular velocity initial all over t final minus t initial. We're going to say that t initial is 0, and we're trying to find when the angular velocity changes direction. So we'll say that the final angular velocity is also 0. And we're left with negative omega z initial over t final. And then we can simply solve. So t final would equal negative angular velocity initial all over alpha z. And this is going to be equal to 6 10 over 7, 4.2 seconds. So what this really means is that omega z is going to be less than 0 from 0 seconds, rather, to 4.2 seconds. And we're not including 4.2 seconds because the angular velocity at 4.2 seconds is going to be 0. So, and then we have angular velocity is going to be greater than 0 from 4.2 seconds to 7 seconds. And we're including 7 seconds. And again, we don't include 4.2 seconds. So this would be your answer for part B. And then let's get a new workbook. And then for part C, we're asking for the total angular displacement. So angular displacement can be derived from the formula. Displacement final equals displacement initial plus the initial angular velocity times time plus half times the angular acceleration times time squared. And then at this point, we can simply substitute in for our known values. The initial angular displacement is going to be considered 0. So we can say -6 times 7 plus 1 over 2. And then we'll keep 10 over 7. And then we'll have 7 squared. And this is going to equal -6.97 radians. So this will be your answer for C. And it's simply from the from the first equation for the final angular displacement. And that's the end of the solution. Thank you for watching.